Thank you very much, and thank you, Peter, for inviting me here. It's a special honor to be here today and to be able to present SkySails, our technology, to you. There is a very nice thing I learned today. I learned today that Nouakchott, as the name, in the old Senaga Berber language means place of wind. So where could I better speak about wind technology than here in Nouakchott, in the place of winds? Isn't that beautiful? I just loved it. And I wanted to share it with you. So, I will talk to you about wind, and not any wind. I will talk to you about airborne wind or high altitude wind. So the winds in about 500 meters height. And there's a very simple thing. The higher you go, the stronger and the more reliable the wind is. So going higher means that we have, here it comes, that we have even more wind than you experience here on the ground. And in 300 meters height, we already have above 12 meters per second as an annual average, which is world-class wind. And this gives us the capability to reduce cost for each cent, for each kilowatt hour to way below 5 cents, maybe even below 4 cents. And what's also very important for the SAREP project is that our footprint is so small. Our carbon footprint is 90% less than classical wind. And here we are doing a carbon removal project, right? So this number is absolutely essential. You cannot come here and build technology that produces more CO2 than necessary. And also a beauty of high altitude wind, where you yield in a constant jet stream, is that you have base load. So the wind is basically there always and everywhere. When I talk about this resource, it's best illustrated with this map. You see on the left a map at 10 meters height, how the wind speed is at 10 meters height. And on the right, you see how the wind speed is distributed in 200 meters height. Why 200 meters? Because there's data available worldwide. 500 meters is not always everywhere available, so we took 200 meters. But in 500 meters, you even have more wind. So you can see that there's a lot of wind in that height. And it matters, now just a little bit of physics, it matters because the wind speed is the reason for producing energy, and it is of course then the exponent 3 that is giving you your yield. Meaning, if you double your wind speed, you 8-fold your yield you get back. This means there's an exponential relation between wind speed and energy yield. And that is why the average wind speed is so important. How does it work? We have a big kite, fully automated, AI-controlled, very, very large. And it flies like a yo-yo, I would say. It goes out, towing a rope. And the rope is coming from a winch, so the wind turns while the rope is being towed out. Then the winch turns a generator. The generator produces electricity. And after about 800 or 1,000 meters of rope length, we stop the kite, and then we tilt it and we twist it so that it comes back down in a nosedive. It flies down. So then we collect the rope, and then the yo-yo starts again. So it goes in and out and in and out. Meaning, you have not a constant power feed. You have a power feed that is going up and down and up and down. But Either you use a battery to average that out, or if you have more than 3 systems, you just let them work against each other together to get a smooth current. So that's very simple. And it's so effective because we use a kite made of textile, a rope made of textile, and we don't need any big concrete foundations, towers, or blades. Very simple. So we reduce a lot. And then, of course, there's a secret, like always, and one of the secrets is our autopilot. That is what you hardly can see. It's a small box, like a pilot, located under the kite. And that is where all the core know-how sits. It controls the complete system, even the station at ground where the energy is generated. So, well, if you look to Mauritania, then with one of our future systems, we can produce up to 8,000 megawatt hours per year with one of the systems. And the beauty is, below the system, you can have agriculture or a forest, which I heard could be essential for SAREP. So you can use the area below the system, and your footprint is extremely small. It's an ideal environment. The SAREP project is ideal for our technology. And of course, when you don't have these spinning blades that spin at almost speed of sound, but you have a kite moving through the air in 500 meters height, it's very, very friendly to birds. So we don't harm birds. And if you then look at the Bangladesh, sorry for my French, I don't speak French very well. So if you look at your wildlife here and your bird life and how important that is to the international bird life, then it's so important that we also protect the birds. And this technology is not only beautiful because you see a small kite in the sky, it's bird friendly and it has low acoustic footprint. I already told you about the CO2 impact, and if you look at the material input compared to solar and CO2, classical wind, then you see that we reduce 90% compared to classical wind and 33%, compared to solar. So it's a better footprint. It's very important. A bit about my company. We have 4 installations out there. So the technology is working already. And now we're starting to industrialize step by step. We have, at the moment, 5 further projects with a total 50 megawatt in project development. And one of the SAREP investors also will back us with cash for industrialization. Our product program is that we have a small machine today, and we started to develop a megawatt machine. And this machine is also the machine we will use in the SAREP project in larger volumes. We want to start with a small machine in the pilot phase. About 2 systems should be enough to feed the pilot phase with all power needed, and then we use a larger product that we just have started to develop. And of course, local production, local jobs. There's a lot of things that you can produce locally, starting with the kites, but not ending there. It's also the assembly of the ground station where the generator sits. It can be done here locally, and it should be done locally, because it doesn't make sense to move these things from Europe here. You can build them here. We will need, I think we calculated about 8,000 kites. So why not build them here? So there's jobs coming, and qualified jobs. And then also it could be an export industry, because we know there's interest from Morocco, from Cape Verde, from Namibia, from Mauritius, and from South Africa. We have projects in development, we have customers requesting systems there. So why not make Mauritania a hub for production for airborne wind, and demonstrate here, where the wind is perfect, that this is a technology that perfectly fits the need of Africa, Asia, and the rest of the world. So thank you very much, and I wish you a good, wonderful conference.